Hello everyone, welcome to another Java video. In this video, we're going to be solving the nth Fibonacci number finding problem. All right, and just to introduce what a Fibonacci number is, it is the approximation to something called a golden ratio, and there is a fantastic Wikipedia article on that. But basically, it follows this, formula where that you can find the nth Fibonacci number by taking the 2 prior and adding it with the 1 prior of a Fibonacci number to find their newest Fibonacci number. So we can assume that the 0th Fibonacci number is 0 and the very first Fibonacci is 1. And with these two values, we can start growing the next Fibonacci numbers onward. So the second Fibonacci number, it is the sum of adding the 0th Fibonacci number and the first Fibonacci number. So you get 0 plus 1, and that gives you 1. The third Fibonacci number is the sum taking the first Fibonacci number, which is n minus 2 of 3, and taking the second Fibonacci number, right? So that we can get 1 plus 1 is equal to 2. So by following this pattern, by growing it from the 0th and the first one, we should be able to get to all values of n that we are interested in. So we're going to be coding this problem. So let's get started. Okay, so we're going to go into system.out.println, enter your nth value. Okay, and then we're going to do see on next line for our string input. That, beautiful. We have that value now. We're going to set a integer upper limit, which is going to be acting as our n. So we're going to do integer parse int our input like so. Okay. Now what we're going to do is our following. Setting up 0th fib and the first fib. Just like our explanation that we had up top here, we are allowed to assume that these values are set like so. So we're going to initialize that value. We're going to call it fib at 0 is equal to 0, and fib at 1 is equal to 1. Okay, and what we're going to do is throughout our program, we're actually going to manipulate these two variables. Sorry, we should call them integers. And at the end, we put semicolons like that. We're going to be manipulating these two values to hold the fib n minus 2 value and the fib n minus 1 value so that we can get the newest fib n value. But right now, we have found 0 and 1. So our goal, our next value that we should be able to create within our program, which should be the second one. And that's going to be our starting point for our for loop. So use for loop to generate the nth values. So we're going to say for int, we're going to call it n here, which is going to be 2. And we're going to say as long as n is less than equal to our upper limit set. And we're going to be going up by 1. So we're going to do n plus plus plus, or n plus plus, sorry. And we have our curly braces like so. And inside, we're going to find, or let's call it calculate the current nth Fibonacci number, which is very simple. We can say that we'll initialize it here in fib n, not found, so 0, not yet calculated. So we can say that fib of n, sorry, too many indentations there, fib of n is equal to current fib of 0 plus fib of 1, semicolon, like so. Then right afterwards, what we're going to do is set up for the next fib of n. That means we need to update fib of 0 and update fib of 1 to hold the newest n minus 2, n minus 1 values. So fib of 0 should be holding fib of 1 value. So fib 0 acts as fib of n minus 2. All right, and then fib of 1 is now going to hold the newest fib of n value so that we can get the next value, which is fib of n plus 1, basically. So we're going to put there. So fib of 1 is now going to be acting as fib of n minus 1. So that when we reloop, we get to calculate the next fib of n, which is going to be n of 3, by adding these two variables, which gets updated right after this value is calculated. Okay, and then we can say, just to get our results, we can have let's see, our input plus Fibonacci number is space plus fib of n semicolon, and let's run our code like so. All right, so let's say we are interested in the second Fibonacci value. We calculated that to be 1. Let's run that again with 3. We get 2. If we were to do 10, we will get the value 55. And let's try the 20th Fibonacci value. We get 6,765. So the Fibonacci golden ratio values do tend to increase very dramatically because we are continuously adding the numbers that came to prior. But that was our solution. So this was a very cool solution where we're really tying up a lot of the basics that we've learned in the very early portions of our course, but using it in a more of an advanced fashion by using it within an iteration to really take advantage of the concept that our variables can update values to calculate your future values going on. This type of programming is called dynamic programming, which you can learn about in the future as you progress throughout your programming journey. Regardless, thank you for watching and stay classy.